All right, good morning. Happy Friday. Hope you guys are doing well. I know it's exciting. It's Friday, and hopefully we're going to catch some good movies this weekend because it's raining out. And I know when I looked out my window upstairs this morning, it looked like snow in this little park across the street. It was just hail, though. It's cold out there. So, a good time to get some popcorn, watch a movie. If you guys see any good movies, let me know. I like to watch movies. I'm so sad I can't go. I love going to the theater, and I think I shared this with you before. Half the time, I don't even care about the movie. I just care about the popcorn. That's all I really care about. So the popcorn with a lot of butter. So that's like right up my alley. So I'll be glad when we can go back to the theater. All right. Well, um, we talked about this graphing. It seemed like people were doing pretty good with this, transformations of square root and cube root. My classes were kind of off kilter there for a minute, but so I'm trying to get everybody back on track here. I think I taught 10-2 to you guys, right? As far as how to write the equations. Is that right? Yeah, but I didn't do 10-3. So today I'm going to not do a whole lot. I'm going to talk about 10-3 and then we're done with module 10. So I would like to take an exam next week. If we were in regular school, I'd rather take it like at the beginning of the week, but it looks like, Tuesdays and Fridays are really the only time we can take them. So it'll look like Friday. If you want to mark your calendar of next week, that'll be 10-1 through 10-3. I'm hoping a lot of you will ace it. So a good opportunity to really boost your grade up. So anybody want to ask me any questions right now about graphing square root? Okay, were you guys able to write the equation? Oh, well, there was, did you guys get my remind of some of the, or at least one of the problems had the wrong order? And I know there were a couple of answers in my book that were wrong. So don't trust the book, trust yourself. If you guys feel like something's wrong, it probably is. So there's a lot of mistakes in this book. And I don't know if you noticed that, but there's a ton of mistakes. When Common Core standards came out, HMH was in a rush to get this book out. So I think they spent a lot of time on Algebra 1, but when it came to Algebra 2, they pushed the book out with a bunch of errors. And there was even a time when they asked us to submit the errors, and I'm like, we're not going to submit the errors unless you pay us. We don't work for free. So if my students and I are going to find the errors, you're going to pay us to find the errors. So yeah, lots of errors in this book. So, all right. So do you guys want to ask me about finding domain and range without graphing? Writing square root functions given a graph, or just graphing square roots? All right. Well, 10-3 looks really similar. We've been graphing cube roots. The cube root, by the way, is the inverse of the cubic polynomial. So the cubic is a snake that goes up and down, and the cube root is a snake that goes left and right. And it does reflect, the inverse does reflect over the identity. So, excuse me, sorry about that. So anyhow, we're going to look at, thank you, we're going to look at 10-3, and mainly going to look at writing the functions for the cube root. Okay, this is California Common Core Standard F-IF.7b. All right, before we start here, anybody want me to graph a cube root? Or are you guys okay? I was not going to do that today. So anybody want me to graph a cube root? Either off that sheet or somewhere else, my notes. No? All right. Okay, so let's look at writing a function, and they'll give you the form. So in this case, that is form 1, and they're going to give you a graph. So they're going to give you right 1 up 7. And they're also giving you right 2 up 9. And it's funny, they don't give you a third point, but who cares? So this point is right 1 up 7, and the other point is right 2 up 9. Now with the cubic, when we wrote the equations, our HK was the middle that divided the graph into 2 parts. The quadratic, HK was the vertex that divided the graph in half. So what do you think HK is in this? God, I'm listening. What is HK, do you think, in this graph?
One seven.
Yeah, my graph is kind of lame. But if I drew it better, you would be able to see that 1 7 was the middle. Go look at your book. I think this problem's coming out of the book in the section 10.3. All right, so we're saying our HK is 1 7. What's A here? A? We don't know. What's B?
1.
What's being multiplied to the X is 1. All right, so what we're going to do is we're going to take the other point like we always do, and we're going to make that XY so we can find A. So we have G of 2, which is X, is equal to A times the cube root of 2 minus 1 plus 7. So G of 2 is Y, so we're going to put a 9 in, and we have A times the cube root of 1. And remember, with a nth root, if it's a cube root, you have to have 3 for 1 to come out. If it's a 7th root, you have to have 7 for 1 to come out. And you can also have a negative under a cube root. Okay, so what's the cube root of 1?
1.
Yeah, so 1 times A is A plus 7, so A is equal to 2. So we can write our equation. So what's our equation? G of X is equal to 2 times the cube root of X minus 1 plus 7. And if you put this, if you define the window right and you put this in the calculator, you should be able to tell that this equation matches the graph. This cube root, by the way, is under the math key on your calculator. So if you go to the math key, you'll see the cube root.
Wait, so Miss Birch,
Yeah.
how did we know what B was? How did we know we didn't know A?
Okay, we don't know what A, that's our unknown A. And we know that B, because of the form, remember this is A and a B is here, and then H and K. So we know that B is 1. Because B is what's being multiplied to the X, and it's 1.
Okay, so B in this form is always 1.
In this form, yeah, you could say that. B in this form, yeah, Eddie, that's good. B in this form is always 1. Yeah, B is always 1 in this form, right? Good. Yeah, I like that. In fact, in the other form, you know, we can say that A is always 1. So, yeah, so let's look at the other form. So we have g of x, they want us to write this, cube root of 1 over b times the quantity x minus h. So that looks like the second form. And once again, we want to find a, b, h, and k. And they're going to give us a graph. So in this graph, they give us right 2 up 1, and they give us right 5 up 2. So they give us right 2 up 1, and they give us right 5 up 2. It looks like this thing has either been vertically compressed or horizontally stretched. So we'll find out. All right, what do you think your HK is in this graph?
2, 1.
I tried to draw it better this time so you could see the symmetry in the middle. So that's 2, 1. All right, here we go. What's A? So see, Eddie, see how there's no A out here? And that means there's a 1 there. And B, we don't know. All right, so we're going to take the other point, which is 5, 2. We're going to make that our xy. We're going to basically solve the equation for B. So we get g of 5 is equal to the cube root of 1 over b times the quantity x, which is 5, minus h plus k. So we have g of 5 is y, so we have 2 is equal to the cube root, and I think, Alexander, you were asking me about this, when is this not a 1? This is not a 1 now. So this is going to be 3 over b plus 1. And so just like when we're solving square root, we isolate the radical. We're going to isolate the radical. So we're going to subtract 1 from both sides. And we get 1. Now here's the deal. We have, you know, when we have a variable under a square root, it's a square root equation. This is a cube root equation because the variable's under there. So what we want to do, if it was a square root, we would square both sides. This is a cube root. So what we're going to do is we're going to undo it by cubing both sides. So remember the index and the power, they undo each other. So we get 3 over b is equal to 1 over 1. And now we have a proportion, so we can cross multiply. So when we cross multiply, we get b is equal to 3. That's a rational equation, right? Because a variable in the bottom. So we can cross multiply. So the equation then is g of x. That's a horrible pen. I got to throw it out. G of x is equal to the cube root of 1 over b, which is 3, times the quantity x minus h plus k. And if you put this on the calculator, you should get the graph. And if you want to know if the points are right, you could always look at the table. So once you graph, you could go to the table feature and look at the ordered pairs and see if you have the ordered pairs that they gave in the graph.
Miss Birch,
Yeah.
why did G of 5 turn into a 2?
Okay. Good question. All right. This G of 5, it's just a label. It's just a name. And that name, just like this G of x right here is equal to y, this G of 5 is equal to y. So what I did is if it's equal to y, I actually put the y in. So in other words, when x is 5, y is 2. When x is 5, y is 2, right? When x is 5, y is 2.
Right.
Does that make sense?
A little.
Okay, so here's the deal. The question is, why don't I just put the 2 up here? Because I'm showing you that I want you to substitute a 5 in for x. So I'm saying, make sure you put a 5 in for x, but after that, this label is called y, and y is 2 when x is 5. When x is, remember this is an ordered pair. So when x is 5, y is 2. Yes or no?
Okay, that makes sense. Thank you.
No problem. Okay, now I'm done with the lesson, you guys. Do you guys want to, do you want me to do another one? You want me to do another problem?
Can you do another one?
Sure. Now, I probably told you this a million times, but I'll tell you again. If I'm ever doing something that's confusing, remember you can watch my YouTube video. And you can fast forward to the problem and then watch the problem, and you can start and stop, start and stop, start and stop. So that's a really good recommendation is to, I need things at a slower pace. So I'm gate, but I need things at a slower pace. That's what I would take advantage of. The teacher's putting these lessons on YouTube. You can go there and you don't have to watch the whole video. Maybe there's a particular problem, that you just want to watch the steps for. The beauty of it is you can start and stop, and you can also rewind. Like, what did she say again? What did she do again? You can listen to it 3 or 4 times, which is what I have to do sometimes. I'm looking for another problem with B because that seems to be the one that's harder. So let me just look in the book really quick at a problem. Okay. I think I found one. 1/3. Okay, here. So here's the second form again. It's the cube root of 1 over b times the quantity x minus h plus k. Yeah, hold on. So they're giving the points left 3 up 2. And the other point they're giving is what? Left 1 up 3. Cube root. All right, so what's your HK? What's the middle point here? The other point would be down here that they're not giving, right? So what would be the middle point? Yeah? So what's A here?
1.
What's B? We don't know. All right, so we're going to pick the other point, which is left 1 up 3, and here we go. So we're going to compute g of x, which is -1. So wherever you see an x, you're going to put a -1. So there's an x, and this is going to be minus a -3, so we want to make sure we write it right, plus 2. So now that we've input the x, we want the y. So what, because this is a label, this isn't a number, this is a name. So what is the number associated to the name? It's the y value. What's the y value when x is -1?
3.
So we have the cube root of x, I'm sorry, the cube root of 1 over b, and this turns out to be, what, 3 minus 1 is 2? Yeah? So this is going to be 3 is equal to the cube root of 2 over b plus 2, because this is 2 over 1, right? So 2 over b. Yes or no? So we isolate the radical, which would be the cube root of 2 over b, and we subtract 2 from both sides. And now, to get the variable out of there, you have to undo the cube root. Well, how do you undo the cube root? You cube both sides and you undo it. So the cube root of the cube of the cube root cancels it out. So you have 2 over b is equal to 1 over 1, and you can cross multiply. So when you cross multiply, what do you get? 2?
Yeah, you get 2.
Now, this is a rational equation, right? Because the variable's on the bottom. This isn't linear. This is a rational equation with the variable on the bottom. We just did that. You cross multiply when you have a proportion. And an easy one. Just cross multiply. Okay, so now we're writing it. It's going to be g of x maybe write it. Okay, g of x is equal to the cube root of 1 over 2 times the quantity x minus a negative 3 plus 2. So your final answer is g of x is equal to the cube root of 1/2 times the quantity x plus 3 plus 2. Now, when I first taught this, I didn't teach it this way. I taught it the way the book is wanting you to memorize a bunch of different things. So if you're looking at the book at all and you're confused, that's why I'm not teaching it anything like the book. So I decided that I wasn't going to have you memorize a bunch of stuff because you couldn't remember it. So that's why we're doing these all the same way. You're finding A, B, H, and K by just knowing what to do, not any memorizing of things. So, like, one thing worth memorizing is the multiplication tables. You know, the multiplication tables are worth memorizing because you use them all the time. We don't want to memorize a lot of things because chances are you're going to forget them very quickly unless you use them all the time. And so we really want to try to make sense of things so that we're not having to memorize and forget stuff. So, all right. So here's what you're going to do. Did we turn this in already? We turned this in tonight, right? Isn't this due tonight?
Yeah.
Yes.
So in your Math Wizard teams, you can talk about some of these problems if you want, but you can't work separate problems. So if your team members finish this, you can ask some questions, but you cannot work on this. Lesson 10.2 out of the book. I also assigned the practice AB, so you can work on that if you want. And if you're done with all that, you can work on lesson 10.3, which I don't think I posted it yet. But you can definitely work on the book problems on 10.3. So today, it's your choice, whatever you want to do, but you have to agree as a group, and you must work together. You're not working separately. So at some point, I might give you the opportunity to work separately, but at this point, I'm trying to get you to work in teams And you are doing a good job with it, but I want to make sure you know what I'm talking about before we stop working on teams. All right, now we are going to report back just to see if there are any questions or problems with anything. So it's 9:56 right now, and class is over at 10:45. So you have a lot of time to get some stuff done. So we're going to be back. I want you to come back at 10:35. So 10 minutes before class is over, you're going to come back at 10:35 to WebEx. All right. Anybody want to ask me any questions about anything?
Did you say you already posted a practice AB?
I think I did in 10.2. Let's take a look. Let me share my screen. Let's go look. Hold on. Bear with me just a second. Ah, darn it. Hold on. Sorry, thought I had it in a tab. So this is my classroom. And I have posted the assignment for 10.2, but not 10.3, but it's going to be posted as soon as I have a chance to do it. So let's see what I did post in 10.2. So see this practice AB at the bottom? I said you can view it, and this practice AB has the problems and the answers right below it. So if I click on it, I'll just show you. Maybe I won't. All right, well, let's see if I can get the assignment percentage. I can get that. Are you guys able to see this?
Yeah, I was able to open it.
Yeah, well, I can't, but that doesn't matter. I don't need it, but as long as you guys can open it, I don't know. My computer looks like it's doing something, but I don't know what it's doing. So sorry about that. It is there though, and I did test it to see if it works, and it did work the other day. It's just not working now for me. Maybe it's because I'm editing. I don't know. Oh, look it. There it is. Amazing. Anyhow, there's the answers underneath. By the way, I think I mentioned this, but you guys need to write your domain and ranges in interval notation. So I know they're saying set notation, but I want it written in interval notation. All right? All right. So I think it's problem number 12 in 10.2. It'll say write the domain and range in set notation. I want interval notation. Okay? All right. I'll see you guys back here at 10:35, and I'll be checking in with the teams to see if you need anything.
Wait, I was confused. Set notation is when you want interval notation. That's when it's like x is greater, less than, or equal to, then, right?
Yeah, I want interval notation And set notation is the one that's real formal that says x such that x is greater than 0. And inequality notation is the one that just says x greater than 0. So there's the 3 notations.
Okay, thank you.
So that's interval notation. Set notation is the real formal one. We hardly ever use that. And then this is an inequality notation, which is incorporated into set notation. I want this because in pre-cal, we use that all the time. So I want you to be really comfortable with interval notation. Okay?
Okay.
All right. I will see you guys back later, but I'll see you in your groups. All right. So we're back. I want to address a couple things. First of all, on the practice AB for 10.2, number 5. A lot of you did notice that this is not the correct order. So as far as math etiquette goes, when you see something in the wrong order, you don't put it in the right order. You assume that whoever wrote this wanted the order to be this way for some reason. So in this particular problem, whatever order you find, you're going to get the right equation. But I just want you to know that if this had been like a vertical stretch and a reflection with a left, right, you would not get the right function by guessing. And I have taught this in the past, but we haven't had a lot of these. This is the first time we've seen it. You have to have these holding functions, and you have to be able to develop the function. And it's not something that I can explain in 5 minutes, because if I show you right now, it's going to blow your mind, and I don't really want to do that. So all I really want you to know right now is when they give the wrong order, they're saying it. There's a reason why you don't change the order to the right order. You just assume that they want that order. When you have to follow an order, you want to follow the correct order. Also, on the same practice AB, number 7, I'm mainly concerned about 7A, but 7B, I feel like it's kind of a ambiguous question, because what do they want? Do they want you to give a math answer? Do they want you to make a statement? What is it that they want? If you want me to look at it, I can, but I'm not really concerned about it. It's an ambiguous question. I can show you, but it's not the most important thing in the world to me, unless you want to see something. All right, so now I just want to take any questions you might have before we leave today. Any questions about anything you're wondering about?
On number 1.
Okay, wait a minute. Number 1
on the text on the book. My bad.
Okay, number 1 in the book. Go ahead. And is this for 10-2?
Yeah, 10-2.
Okay, go ahead.
When we're graphing, do we just graph both of them on the same graph?
Yeah, that's what they're asking. So
Okay.
they're saying they want square root graphs. So the parent is 0, 0, right 1, up 1. So there's square root. And the reflection would be 0, 0, right 1, down 1. So there's your square root of, what did they want? Of negative square root of x. So there's your square root of x, and there's your negative square reflected over the x-axis. And then they're asking you to write the domain, range, and in behavior. And so when you write the domain and range, make sure you write it in interval notation. And the end behavior, you know how to write that. As x goes to infinity, f of x does what? As x goes to negative infinity, f of x does what?
Ms. Birch?
Okay, thank you.
Go ahead, Alexis.
I have a question about that same problem. So
Yeah.
for the end behavior, what would it be as x goes to negative infinity?
Okay, so you want me to do this one, this end behavior? So as x goes to the right forever, the function is going to the right forever.
Yeah, I got that.
As x goes to the left forever, the function is nothing because there is no behavior. It stops, right? So there is no behavior. Behavior is something that's occurring. So there is no behavior. Right?
Yeah, thank you.
Okay. All right, anything else?
To add on to that, for negative square root of x, would it be as x approaches infinity as x approaches negative infinity? Or
Say that again.
so because it asked us to write it for both of them, right? So would we write that again, just put f of x approaching negative infinity?
Yeah, as x goes to this one, as x goes to infinity, the function is going to infinity. As x goes to negative infinity, f of x is not doing anything. I don't like the way the book wrote it because my book only wrote the one is like, what happened to the negative infinity? You know, so they didn't write it assuming that you know what's going on, but they should have written both.
Wait, wouldn't f of x approach negative infinity because it's going down?
You're right. Hold on. Okay, so as x goes to the right forever, the function is going up. As x goes to the left forever, there is no behavior. On this one, as x goes to the right forever, the function is, this should be negative infinity, right? Is that what you're saying?
Yeah.
Yeah, thank you. Thanks, Eddie. You're right. That should be, yeah, as x goes to the right forever, but y is going down. Thanks, yeah. I was so focused on this statement and this statement. What I'm saying is the book didn't bother to write these two statements, and you're probably wondering, why did they do that? Why? Well, they should have. They should have written both. But the reason, you see the reason why they didn't though, right? Because there is no behavior when you go to the left forever, and on this one, when you go to the left, there is no behavior. So they just omitted it. All right, thank you. All right. Anything else? All right, so see how, okay, so not only do you guys in your teams help each other out by, oh no, I didn't get that. Oh yes, that's what I got. And you're working together. You see how you help me to be better too? Because as a teacher, I mean, I cover the most important things, but when you question me, if I did something wrong, or you're questioning me about something maybe I didn't cover thoroughly or whatever. So you guys, by talking back to me and making statements to me, you're helping me to be better. And it all works together. So collaborating is a really good thing. Okay, anything else, guys? Okay, well, like I said, planning on an exam next Friday at 8. At some point, I'll be posting 10.3, but I will be going on with the lessons. So we're not going to spend all next week studying or anything like that. So hopefully this exam will be pretty straightforward and easy. So hope you guys have a great weekend, okay? Have a great weekend, and I will see you soon.
Have a good weekend, Miss Birch.
Thanks, Son. Thanks, Son. Bye. Okay, bye, guys. Bye, Diane. Bye,
Bye.
guys. Bye, Alessandra.
Bye.
Bye, Eddie. Bye, everybody.